13 participants have come, and I don't know, it's like now 2 o'clock. Okay, I hope we can start the session. All right, so methods you are already familiar. Java basically it is object-oriented language. Naturally, you cannot do anything without developing a class. Class is the way in which, right? So there is a keyword called class in object-oriented languages. Using that, you can create classes, right? A class is useful to create objects, basically. A class is useful to create objects. Anytime that you have any difficulty, please raise so that. So class is a mechanism by which you can create classes of your interest where like what kind of attributes you want to store within the class and what kind of methods using which you want to access the attributes of the data within. Essentially, class is a mechanism by which you can encapsulate, you can put together the data items and the methods that will operate on that particular data item. That is a style, like one of the styles of programming, popular methods of programming is object-oriented programming. And within the Java classes, you can have two types of methods, basically. Two types of methods. One is a static method, the other one is a non-static method. Basically. The static methods are helpful. They are helpful to access methods using the class itself. You don't require an object to invoke a method. Normal scenario is you create objects and then using the object you try to invoke the methods and all. That is one style. So when you invoke a method on an object, you naturally are able to access the data within the object. Either you can modify or you can access that particular thing. I'm assuming probably certain background to all of you, like certain programming background. And as we are writing small programs, you will get used to it. And probably you may have to even what it is, go through the textbooks, install the software, write small programs. This is the only way, right, to learning things in a step-by-step manner, incremental manner. Don't delay or postpone. Always, uh, every day, have some 2 or 3 hours of practice on programming that will easily make you to understand. Okay, so static methods are the ways in which you can actually access the methods using the class. And how do you normally invoke the methods and all that? By using something called dot notation, right? Dot notation. So that means you can normally say like your class name dot followed by the method name. If it is so, all of this like follow the online etiquette. Whenever you want to speak, only then you should unmute. All other times, please mute yourself. Mute yourself so that any kind of noise that is happening in your surroundings will not be picked. The regular class, only I must speak. And whenever you have a doubt or you have a question, only you should unmute and then speak. All the times, please kindly mute yourself. Don't repeat it. Slowly get it. So there are some people like still. That's why I'm asking. If you do not know how to follow the rules, basically Kalyani, there is a your voice is coming here. Please unmute yourself or mute yourself, right? So follow the rules. Like I'm not expecting you like to again repeat these things. Okay, thank you. Coming back to our session here. So we use the dot notation in order to access the individual method. In fact, if you pay attention to one of the very earliest what it is, the class that we normally access, even in Hello World kind of it, is there is a class called system class, right? There is a class called system that is present inside a package called java.lang. Complete name of that is java.lang.system. So by default, java.lang is imported, so you don't have to expand all that. So system is a class that is present inside the java.lang. Now within the system, there are certain attributes and there are certain methods. In fact, all of them can be considered as static attributes and static methods. That's why you are able to access them through the name of the class. So there is an object called out object inside the system class. Remember that. That's why you are actually trying to access that using system.out. That out is an object actually, object of print stream class. So that whenever you want to write something onto the screen, you make use of it. So this out object has got certain what you call out object has got certain methods that you can invoke, and some of the popular things happens to be print, println, and printf. There are many others. So by using this, you can write something onto the screen, essentially. So you are using the dot notation in order to access the methods or attributes present inside a class or inside an object. That is the kind of notation that people try to use in object-oriented language. Now, there is a main method that is to be developed in every class that you want to run that class as a program. If you want to run any class as a program and you want to see the result, then that class must contain a static method called main method. So only when the main method is written inside a class, you can use that class to run the program, run that as a program. And always access specifiers you also have, so that whenever you want to access it from outside, you also make it public. So public static. And because the main method doesn't return anything, that's the reason why it is void. So this is the signature for the main method anyhow. So here, essentially, it takes the command line arguments. So because arguments means there will be items, and anything that you enter from the keyboard along with the command, those all will be strings, right? String of characters. So that's why this particular thing will be the signature for the main method. In today's class, like we will move on to a little further, like something called recursive methods. So already you are, I'm assuming that all of you are already familiar with control structure, right? Control structure in popular languages like C, C++, Java. Most of those languages have a similar control structure. You have conditional control structure, you have repetitive control structure. Like if then else kind of thing, if else. Similarly, this is one control structure, you can say. Similarly, you have while do, right? While control structure. Similarly, do while, right? Do while you have. And then you have for loop. You have a for loop in C language. Java also supports all of them as it is. And then switch case, right? Switch case is another. So all these things are already there. And I am assuming that all of you are already familiar with it. Right? With that assumption, I am just proceeding further. So wherever you are normally, you may have certain doubts and all that. In case you have doubts, even here you can read. If you want me to repeat, I can, no issue. But there is no point in wasting when you already know it. Okay. So these are the control structures that are there. And then functions in C language. They are called as methods in Java language. That's the only difference. So nothing else. Computer science is full of jargon, and there will be many terms that mean one and the same. So if you don't know the meaning, then you will, by the word, you may get confused or maybe perplexed. So it may be something totally different. Method is nothing but a function. Essentially. Okay. Now recursive methods. Now we want recursion. Recursion is one of the strongest, what it is, features of modern languages. In fact, more so with respect to functional programming. Functional programming is another one where a lot of things are happening, especially in the nowadays with the advent of Python language. Java also is provided with some of the functional features. We'll come to that a little later. Okay. So right now, recursive functions are recursive methods. For example, there may be certain scenarios in in the real world scenarios. In the real world, there may be certain situations where a function may invoke itself recursive. The function may call itself. In order to find the answer for a particular method, you have to call the same method with different parameters. You want to call the same method with a different parameter. Most likely, the parameter might be a smaller parameter than the parameter with which you start. For example, one of the popular recursive methods or functions is factorial. Right? Factorial is a very popular recursive kind of entity. So here, normally you are saying factorial of n. Factorial of n is defined as, right? So we say that this is equal to 1 if n is, let us say, less than 2. That means if n is equal to 0 or n equal to 1, factorial of that is 1. Right? And this we normally call it as a base case. Right? Base case you will have to call it. There is a small problem with the keyboard. So base case means a scenario where you don't call itself recursive. Right? For certain parameters, for certain data that the method is you are invoking, you don't call itself recursive, because otherwise if you call itself forever without any condition, then when is that you are going to get the final result? Never. So it is a base case that will stop the calling of the function repeatedly. This is the stage where it's going to stop, so that it will return the value back to the calling, and that in turn will return the value back to its own calling. So it goes on in that particular manner, and is equal to n times, right? N multiplied by factorial of n minus 1. When is that? Otherwise, we can say. Right? Otherwise means if n is greater than or equal to 2. That's what you really mean by. If n is greater than or equal to 2, what is the value of factorial of n? Factorial of n is nothing but n times factorial of n minus 1. Factorial of n minus 1. So this is the actual definition of the factorial. So once you understand, once you know what is the actual definition of the particular recursive mathematical thing or whatever, then developing this into a language or this into a program becomes very easy. It is as simple as almost from the definition you can. For example, in the case of the Java language now, if you want to convert the same into a Java method, Java recursive method, it is likely to be the following. Public, because it is a method that you want to invoke through a class name, so it is static. And then because this method returns a number, right? It takes a number and returns another number. So that means you have to specify the return data type of the method that it returns. So factorial returns an integer as a result. So you say int and then factorial of. Now you are actually writing a part of the Java program, only the method. Later we will write the complete code. So that this will be kept inside another class. As simple as that. So public static int factorial of. Now it requires a parameter, right? Parameters that you will have to always specify what is the data type of the parameter and what is the parameter name. So it's going to take an integer as a parameter. So you say int followed by probably n. You can give any name. So for the time being, you are saying n here. Yeah. And after that, curly brace begins as usual. Now the logic will be so simple, right? Here. The logic will be so simple that, for example, so what is that? It's the same condition. If n is less than 2, so what is to be done? What is the value of factorial of n? If n is less than 2, it is equal to 1. So in the case of the Java language here, the syntax will be, you will have to return the value. Whenever you know the value of the result, if you know the value of the result, you just simply return that particular result, that particular value. So return what? Return 1. So if n is less than 2, return 1. That's what it is. Otherwise, the control comes below. If it is less than 2, it will return the value back to the calling place. Otherwise, it control comes to the next line. You can put else part, even otherwise also is okay, because like if that is the case, it goes there and otherwise here. So you say return what? So otherwise, what is to be returned? You have to return n times factorial of n minus 1. So return n times factorial of n minus 1. That's it, right? The method is as simple as this. This is what is called as recursive methods. Where, so for certain scenarios, certain real world scenarios, recursive solutions may be much easier to develop, easier to understand. In such scenarios, we normally better, like, I'm not saying that for everything you should go for recursion and all that. What all I am saying is that you should be familiar with developing recursive solutions also if required. Recursion has got its own cost, right? So if too many times you call itself recursively and so on, it is likely to take more space and it is likely to take more time also. More time also. I'm not going into those details because that you can read for yourself. I'm focusing more on developing solutions. So once you know that with this background, by reading some other books, or maybe examining the internet and all that, you should be able to understand further. So this is a factorial of n, right? So it is a very simple thing. Now we can probably write a small like a program, complete program, and let us try to complete it. So here, in order to verify that, so we will be developing a number of like what we call recursive methods. So let us actually create something here, public. So now we are going to develop a class, right? Public class. So its name is REC, recursion, and curly brace begin. So recursive class, we are actually trying to develop. Then, so this is that. And all of them have to be left line with some kind of indentation. Now let me save it to begin with. So the name of this must match with the name of the class. So REC stands for recursive dot name dot Java. So it is saved there, and this is the actual class name. All right. So up to this we have done. Now we have to actually get the what we call the main method. Main method is there here. Probably we can copy this part of it. So public static void main of all. Right? This is actually taken from probably NetBeans and all that. So here I am avoiding so that you can actually see the bigger screen. Only the program you will see. That's the reason why we are actually doing all this. So, and we will be using the command line arguments. You are already familiar with that. So the first parameter you are going to get in the command line argument. So we require an integer here. So declare an integer variable int n. And result, if you want to get, you can say R, two variables. Now you are likely to get, let us say, n is equal to. So through a command line argument, we are going to get, let us say, what you call a number. But because you are going to get always strings here, so you need to convert them. So in order to convert what it is, a string into integer, already in the last class we have seen, integer dot parseInt. Integer dot parseInt. There is a method called parseInt that is there inside an integer class. It is a wrapper class useful for conversion from a string to integers, integer to string, that kind of stuff. So parseInt, where from are you going to get the data? Through a command line argument, and the corresponding parameter is this R. So you say R of 0th parameter will contain the actual first command line argument. So R1 will contain the next argument and so on. So this is there. So you are converting. You are converting the command line argument and putting it into n. Now, if you want to know what is the answer for factorial and all that, so you can say R is equal to factorial of n. Right? Factorial. So you are making a call onto that. You see here, main is a static method. A static method can invoke another static method. Remember. But a static method cannot invoke a non-static method because non-static method can access the data of an object. Data of an object. And there is no data here. Like the static methods do not have any objects with them. So that's why these simple rules you'll have to remember. Static methods can call other static methods. But static methods cannot call other non-static methods. Anyhow, so R is equal to factorial of n. Now, here you can say, so let me use a printf, what all of you are familiar with. So that I'm going to say factorial of followed by percentage d, right? So some number will come. Factorial of so and so is another number, result, percentage, and then a new line. This is what the output you want. Now you have to pass on the parameter, two parameters. One parameter for percent d, another parameter for percentage, another percentage. So factorial of what? N. And then result is R. Here itself you can also call, in fact, instead of R, you can say factorial of n also. That is also possible. So I think all of you are following what we are actually doing. And then the entire. So now let me save it. Save this particular thing. and save. Now, in order to compile this and so on, you can set the Notepad++. In fact, I'm using a different method today. I cannot, but we have the command line arguments. We have the command prompt, right? So we can make use of the command prompt and then compile it, all that kind of stuff. So what we will do is, let me copy the path of this particular thing. Say that it is already there. Current directory file name to clipboard, current directory path to clipboard. So anyhow, so let me just put this command. Go ahead, not that. Okay. So this is the command prompt. We should be able to increase the font size and all that probably. Let me change the font size. Somewhat okay now, but we can change the colors also. We are actually using the Zoom. So this is what you are going to see. You may have to rejoin once again after another 10 minutes time, not immediately. Background. We did not save it probably. Select this thing, select that. Only for this. Let me take the. I would like to go into the directory where this is there. We'll have to full file path to clipboard. Okay, so this is the actual path, and we should be able to find all of them. Like record rec.java is there. Now I want to compile it by saying java c followed by rec.java. So and then how are you going to run it? By just simply saying java followed by rec, and then command line argument. You have to pass on the data through the command itself. So for example, 5 factorial, you are also interested in 6 factorial, let us say. Because you are only accessing the first argument, R's of 0, only it's going to find the R that for that particular factorial of 5 is 102. So like this, you can actually do that. Right now, we will again come back and join because it probably is getting time over here. That's a better mechanism. I'm just stopping sharing and all that. We will kindly join immediately after another. Just the remaining meeting time, 7 minutes is staying. Probably it's 7 minutes is there. Let me complete a little bit more. So I think all of you are familiar with what we are actually doing. Now that in case you want to find the factorial for all the numbers that are going to be given, then how are you going to do that? For every number, right? So what we can probably do is in such a case, so we say for, right, within this thing. So for every argument, we have to do it now. So you have two types of for loops in Java. One is the standard C style for loop. The second style today we will work on. For every item within an array, if you want to repeat your for loop on every item of an array, ours is an array, right? Ours is an array of strings. You want to work on every item within the arc. In such cases, what is the data type of the arc? It is string actually. So you say string yes colon arc you specify. When you do like this, so now this part, this part, this part, all of them, you will have to have an indentation there. And this is over, and here the this must be closing of the curly brace. Right. So now you want to find out, you want to convert the everything. So as you can see now, for all string s colon r, that means every time it goes through the for loop, it is going to get the next item from the args array and put it into s. So first time you are going to get the first argument into s. Next time second argument. So for everything you want to find out. So that means now parse int of what? Now the string is there in yes now. So you'll specify like in this particular manner. And then you are finding out this thing and factorial of so and so, all that. So this is the way in which you can actually, what it is, repeat for every command line argument doing something, right? It is another small change here. Another 4 minutes time is there. So we can now go back to this and again recompile. So like this, you can compile it once again. And if you want to run it now for two arguments, it's going to say factorial of 5 is so and so, 6 is so and so. So like this, you can repeat for several items, any number of items that in which you are actually interested, right? So you can always give in this particular manner, right? So we will come back to and then continue on the same session. For the time being, let me stop sharing and then record. Also, we'll have to pause it and save it.